Okay, so today's lesson is on functions, domain and range. So we've touched a little bit on domain and range. We talked about them in relations in the last lesson. So now we're going to apply domain and range concepts to functions. You do have a ditto to do for homework, so make sure that gets done and submitted to Google Classroom. Okay, so first of all, what is a function? Okay, so function is a special relationship between values. Now, what do I mean by that? Well, specifically, each input, which remember we discussed in the last lesson, are your x's, has exactly one and only one output. So each input has one and only one output. And remember, those are your y values. Okay, so input are your x values, output are your y values. So what makes a function is that every input has one and only one output. Every x is paired with one and only one y. So another way you can kind of think of this is that the x's can't repeat. If you see an x being used more than once, then it's not a function. Okay, so I'm going to give you some examples here. So an example of a function. Well, we saw this similar notation with the fancy little curly Q brackets in when we were talking about relations, right? So I'm going to give you some sets of ordered pairs here, and then we're going to go through why they are or are not a function. So we've got 0, 6, 5, -2, 7, 9, and 11, -1. Now this I have written in the box that says function, all right? Now remember, if you look at the definition we just wrote here in red, a function is where each input, or x, has one and only one output. Actually, I think I have a right-o there. One and only one output. Okay, so if I take a look at these ordered pairs here, and I look at my x's, I have a 0, I have a 5, a 7, and an 11. Each of my x's is used once and only once. None of them repeat. That is why this is considered a function. Whereas, let me give you a different example in the other box. So say I gave you these ordered pairs. -4, 1, -1, 7, -1, -2, and 5, 6. Okay, and now I take a look at these x's. So we have a -4, a -1, a -1 again, and a 5. So here you can see that these two x's, -1, they're reused. All right, they repeated. All right, and in a function, you are not allowed to repeat your x's. Every x, every input, is paired with one and only one y, only one output. So you cannot reuse your x's in a function. Okay? So if we take a look here, and again, at any point, pause the video if you need to catch up on the notes. So if we take a look here at some more examples, it says determine whether the given relation is a function. So we're just going to answer yes or no. All right, so these first four questions are exactly what I was just showing you. So we're going to zero in on looking at the x's. So here in number 1, we have a 5, a 3, a 2, a 0, and a -1. Every single one of those x's is different. None of them repeated. So yes, this is going to be a function. Now let's take a look at number 2. Again, I'm going to look at those x's. I have a -1, a 0, a 2, a 3, and then a 2 again. So you see here that the 2 is used in two different spots. It's used twice. We're repeating that x value. We are not allowed to do that in functions. So this one would not be a function. Okay, that's literally all it is. So I would take a second, pause the video, and try 3 and 4 on your own, which are exactly the same thing. Okay, so if we take a look at number 3, again, looking at my x's, x's only. You want to see if those x's repeat. So I have a -4, a -3, -2, 1. So far, so good. But then the last one is a -3 again. So here we have a -3 used twice. Once again, we are not allowed to do that. So this is not a function. No. All right, now same thing with number 4. Take a look at those x's. We've got a 1, a 2, a 3, a 4, a 5. Every single one of those x's is different. None of them repeated. So yes, this one would be a function. It's that simple. Now that's the definition of what makes a function, but they can show you this data in different ways. So here they listed these numbers as ordered pairs. They could show it to you as a table, which we're going to see next, or they could show it to you in a mapping diagram, which we'll see after that. So I'm going to do 5, 6, and 7 for you, and then I would pause the video and you try 8, 9, and 10. Okay, so for number 5, once again, I'm just looking at all my x values. I have a 3, a -1, a 0, a 2, and then a 3 again. So as soon as I see my 3 here is used more than one time in that x column, because again, it's always the x's that we are paying attention to for this, okay, that means that automatically this is not a function. You cannot repeat your x's. And I'm just going to do that for each table, looking at the x column. So we have a -4, -2, 1, +2, and 5. All of these x's are different, so that's fine. That's a function. And then in number 7, same thing. We have a -5, a 3, a 0, a 1, a 2. Every single one of those x values are all different, none of them repeated. So yes, this is a function. So we had 1 no and 2 yeses. So again here, I would take a second, pause the video, try 8, 9, and 10 on your own. Same exact thing. Okay, so for number 8 here, all right, we have, again, looking at all of my x's here, I can see right away that I have a 4 used here, and then 4 is used again later on. So we have repeating x values, not allowed to have that. So no, this is not a function. Now, for number 9, here's all my x's. And taking a look here, just be careful, -8 and +8 are not the same thing. 4 and -4 are not the same thing. So we're in the clear here. All of these x's are different, so yes, this is a function. And then for number 10, once again, it is the x's that you are paying attention to for this. And they're all different. 1, 2, 3, 4, 5. None of them repeated. Since they're all different, no repeats, this is a function. Okay, so 1 through 4 gave us the information as ordered pairs. 5 through 10 gave us the information as a table. Now the last 3 we see here on the page, 11, 12, and 13, are going to give us the information shown to us as a mapping diagram. Okay, and we talked about this in an earlier lesson where a mapping diagram can be used to determine if something is or is not a function. So basically when you're looking at a mapping diagram, if you see more than one arrow coming out of the same number for the x bubble, then you know that's not a function. So again, it's the x's we're paying attention to. So if I take a look at my x circle here, right, I've got a -3, a -1, a 2, and a 4. And each one of those numbers only has one arrow coming out of it, which means that each one of those numbers, those x's, is only paired with one y. So that's okay. That's a function. Whereas if you look at number 12 next to it, again, we're paying attention to the x bubble. Here's a -4, a -1, a 2, and a 1. I see here that the -1 has 2 arrows coming out of it, 1 to the negative 1 and 1 to the positive 7. And that's not okay. We cannot reuse, right? We see an arrow going there. We see an arrow going there. That is a problem. So since that particular x value is being used with more than one y, that means this is not a function. You cannot reuse those x's. Okay? So I take a second, pause the video, try number 13 on your own. Okay, and once again, it's the x's we're looking at. So looking in that bubble, I have a -1, a 0, a 1, and a 2. And every single one of those numbers only has one arrow coming out of it. So this is okay. This is a function. None of those x's are repeating. Okay? That's as simple as it is. Yes or no? Did the x's repeat or not? Okay? Now, there's one other thing they can do to you. Instead of giving you the numbers visually in either ordered pairs, a table, or a mapping diagram, they could give you a graph to look at. And if they give you a graph to look at, then we want to be considering the vertical line test. So it says, when given the graph of a relation, the vertical line test can be used to determine whether the relation is a function. The vertical line test states, okay? So, vertical line test. If a vertical line and remember, a vertical line would be a line that runs up and down, so in case you don't know that, intersects a graph more than once, then it is not a function. Okay, and again, I'm going to give you a visual for that, all right? So say we made ourselves a set of axes here, okay? And I'm just going to draw a quick little set here. All right, get myself two sets of axes, because we're going to do one that's a function and one that's not a function. So I'm going to just give myself two sets of axes. And remember, axes should always be labeled x and y. All right, just nitpicking here, but just always want to try to have good habits. All right. Now, say for the function here, okay? So say I give you a graph like this. Okay, that's the graph in blue. The vertical line test says that I should be able to draw a vertical line anywhere I want in that picture and have it only touch my graph once if it's a function. So I'm going to grab my dashed line here, and let's see, I'll make it a green line so it stands out. Okay. Now I'm just going to draw myself a vertical line. Now, if this is a function, I should be able to take this vertical line and put it anywhere I want on my blue graph, and it is going to hit that graph one time and one time only. And that's what happens here. No matter where I put that vertical line, it is only going to hit my graph one time. So yes, this is a function. Now, for not a function, well, say I give you something like this. Okay? Simple circle, right? Now, if I try to do that vertical line test again, so I'm just going to copy this line here. Oh, this will let me. Okay, I'll just get a new one. There we go. Okay, so here's a new green line. All right. Now, again, same thing. I should be able to put that vertical line anywhere I want if my function is in fact a function. So if I take this vertical line and I put it right there, then I'm only touching once. That's fine. Whoops, I moved our circle. If I put it right there, I'm only touching once. That's fine. But I should be able to put it anywhere. And if I just move that line slightly, you can see that it's going to hit the circle at the top and at the bottom in 2 spots, which means this is not a function. Okay? In order to pass the vertical line test, then your vertical line must hit your graph in one and only one spot. Okay? If it hits more than once, then it's not a function. Okay? So, below this, we have a whole bunch of pictures that we are basically just going to see, do they or do they not pass the vertical line test? So I'm going to go through the left column with you, and then I would pause the video and you try the right column on your own. All right? So all I'm going to do here is I'm going to get myself another vertical line here. And I like to have like an actual line in front of me so I can see it. I'm going to make it red so it's nice and visible. Whoops, that's not a vertical line. Hold on. There we go. Okay, and now I'm just going to use this line to help me do each one of the questions. All right, so now this first graph might look a little weird to you, okay, because nothing's connected, but that can happen to us, okay? That's what we call a discontinuous graph. So it's just a bunch of plotted points, right? They're not connected together. So if this is a function, I should be able to put my vertical line anywhere I want and only hit one of these points at a time. So if I put it here, fine. Here, fine. Here, fine. But if I put it here, you can see that it would touch both of these points. And that's a problem. So this is not a function. Okay, now I'm just going to work my way down, and I'm going to keep doing this same process. So I'm going to use this same vertical line here. And now if I look at my graph and I move this vertical line anywhere I want, no matter where I put it, I am only going to hit this line once and only once. So this would be a function. Let's look at 18. Okay, again, I should be able to put this line anywhere I want. If I put it here, fine, it only touches once. If I put it here, fine, only touches once. But as soon as I try to move it anywhere else, like maybe here, it's going to hit top and bottom. This is similar to, actually, it's exactly the same as the function I showed you earlier, or rather the example I showed you earlier of why it's not a function, because this would hit the circle at the top and also at the bottom. As soon as it hits more than once, then it's not a function. And number 20. Okay, now you might be a little confused here, wondering, well, what is the graph? Well, here's your x and y axis. The graph is actually this line right here. Okay, so again, in order to be a function, I should be able to put my vertical line anywhere and only touch once. Now, the problem here is that the line that they graphed for us is a vertical line. So if I put my vertical line on top of another vertical line, it's going to touch everywhere. You see that? See how they're flush against each other? Every single spot I try to put this line, it's going to touch because it's 2 vertical lines. So they really just lay on top of each other. And that's a problem. Can't have that. Okay? Okay, sorry about that. We had an announcement. All right, so since this vertical line would lay directly on top of the other vertical line, it would touch everywhere. And as soon as it touches more than once, then it is not a function. Okay, so at this point, I'd pause the video and you try the right column, 15 down through 21. Okay, so for number 15, again, you should be able to put the line anywhere you want. Whoops, that's changed back. Okay, and for this particular problem, okay, 1 point, 1 point, 1 point. Now, notice it is overlapping with the y-axis, but that's okay. The y-axis is not one of the plotted points. It's not part of the graph. It's just the axes, the coordinate plane that we're graphing these points on. So that's okay. 1 point, 1 point. Okay, no matter where I put this line, it is only ever going to hit 1 point at a time. So yes, this would be a function. Okay, next one, working down, number 17. All right, if I put my vertical line here, it looks like it's not an issue. But as soon as I try to move it over to the left at all, we can see that it hits the top and bottom of the graph, both. This is what we call a sideways parabola. And we're going to talk about parabolas when we do our unit on quadratics. But since this graph is on its side like this vertical line will touch both the top and the bottom, which means this is not a function. Okay, now working our way down, number 19 here, we have a good old absolute value graph. Okay, anytime you have a graph that looks like a V or an upside down V, that's going to be an absolute value. We're going to talk about those this year as well. And again, I should be able to put this vertical line anywhere I want and only hit this graph one time and one time only, and that works here. We don't have any double hitting spots. And last one, 21. Okay, once again, we're going to take our vertical line and we're going to move it along our smooth curve here. And as long as that vertical line doesn't hit the graph in more than one spot anywhere, then we're okay. And here we're fine. No matter where I put that line, it only hits my graph once and only once. So this would be a function. Okay, so that's it for this lesson. Don't forget to do your homework, and I will see you next time.